So we've already learned that slope is rise over run. And then we've learned that the formula for slope is y2 minus y1 over x2 minus x1. Okay, that's how we can calculate the slope between any 2 points. Rate of change, mean slope. Okay, so recall that a linear function is a function whose data points lie on a straight line. So if you plot the points and put a ruler, they should all be on that line if you were to graph over them. Okay, meaning that there's a constant slope between each point. Points are said to be collinear. That's how we say it. We don't say collinear. We say collinear, even though there's 2 L's. I don't know what, but anyway. Co means together. So all of those points together lie on the line. So the line down below there to the right has 4 distinct points shown. There's obviously more points because it's continuous, but we've pointed out some nice points, A, B, C, and D. What is true about the slopes of line segments A, B, B, C, etc.? So remember, we can use the lowercase m. So if I find the slope of line segment AB, I'm not going to use the formula. I'm going to form a triangle. From the left point, I have to go up and to the right. So up 2 to the right 3. Then if I find slope of BC, up 2 to the right 3. Slope of AC. So now I'm going from A to C. So I'm going up 4 to the right 6, which reduces to the same thing, 2/3. If I go slope of AD, A to D, I'm going up 6 to the right 9. 6 over 9 reduces to 2/3. And then BD, up 4 to the right 6. I'll put it over here. Reduces to 2/3. So between any 2 points, the slope of that line is 2/3. Okay, it is a line. All of those points lie on the line and have the same slope between them. So if you pick any 2 points on this line, what will be the slope of the line segment that connects them? 2/3. Okay, so I guess up here, what is true about these? I found them all. Here we just say they're the same. I didn't actually state that out, I just showed it. Okay, so the points A, B, C, and D from the graph above are said to be collinear because they lie on the same line. If points P, Q, and R are collinear, what conclusion can be made about slopes of PQ, QR, and PR? Same, they're equal. So the actual values will be equal. So slope PQ will equal slope QR will equal slope PR. So I didn't use the word, I just used the letter M because that means slope. All right, so now we have to determine whether or not the following sets of points are collinear. Okay, so you have to calculate the slope between any 2 points. Okay, so you might do slope of DE and slope of EF. So I'll give you a couple minutes, you calculate the slope. Remember the slope formula, again, I'll write it out for you. Determine means show work, so I need to see you putting those values into the slope formula and then simplifying it. All right, so your first value in each of these are your second point. So if I'm going D to E, then this is going to be my second point. This is going to be my first point. So that's going to be 2 minus 4 over 0 minus negative 4. And reduce to lowest terms. You can do DF if you want. I'm doing DE and EF. If you want to do DF, go for it. But you have to do two sets of points. So EF are these. So I'm going to go from my y value of my F minus the y value of my E over x value of my F minus x value of my E. Okay, and then simplify that. Rise over run, y over x. Yep. So it is EF. Okay, so that means these are collinear. Oh my gosh. Read or listen. Read right there. Okay, so the slopes are equal. So those points are collinear. Slopes between any two sets, any two pairs of points have to be the same. Think about it. If you had 3 points like that, and you find the slope between those two and compare it to the slope between these two, they're different. So that's those 3 points don't lie on the same line. If you did it with this pair and this pair, their slopes aren't the same. They don't lie on the same line. Okay, they are not collinear points. Okay, so now the next set, same thing. I'm going to go, in this case, I'm going to go slope of JK equals, and then maybe I'll go slope of JL. Okay, so starting from the same one. You could go slope of JK, slope of KL. You could go slope of KJ, slope of KL. No matter what, the slopes should be the same. Any two pairs of points, any order of the points. Okay, the biggest thing is the integers. Make sure you've got them in the correct order and you know your integer rules. And then if it's a negative over a negative, it obviously simplifies to a positive. The formula. That would be k to j. This is, if I'm going from j to k, this is my second point, and this is my first point. So the second y minus the first y. Second x minus the first x. Order. Second one always goes first. Okay, so those slopes are different. They're both positive, but they're different slopes. Okay, so slopes not equal. Not collinear. Slopes are not equal, therefore not collinear. Okay, so determine means show your work. So same thing in question 2. You're given 3 points, but take a look. Point C, we don't know both coordinates. Okay, so we're going to have to find the x-coordinate, but it doesn't matter in part A. It says determine the slope of AB. So do that. It's all numbers. Plug it into the formulas. Yes, ROC is the slope. It's the same.
So ROC basically means M.
Yes. I said that 4 times today already. Yes. Equation has an equal sign, comparing it to something else. Expression is just an expression. It's not equal to anything in particular.
So I would have put M.
Oh yeah, yeah, you can put M equal. Yeah. Yep, it's 1/3. Okay, so that's the slope of AB. Then it says write an expression for the slope of BC. So that means it's going to have a variable in it. An expression is an algebraic expression. So it's not going to be, we're not going to be able to make an equation yet, but we can still use M, BC. And so notice our y value of C is 1. Y value of B is -3. Our x value, guys, can you stop talking? You have the most questions of anyone because you're not listening. Okay, so then in x's, C is x, and in the run, we're looking at the difference in the x values, so x minus 5. So we can't simplify the bottom, but 1 minus -3 is 4. And we leave the denominator the same. So that's an expression. It has x's in it. We don't actually know what the slope is. Then in part C of this question, it says, if A, B, and C are collinear points, what can you say about the slopes of AB and BC? Okay, they have to be equal. So the slope of AB has to equal the slope of BC if they're collinear, and it's telling you that. So now use your result from that to determine the value of x. So our equation then, slope of AB is equal to the slope of BC. Oh, I guess I'm going to have to do that arrow just a sec. Okay, so now we have to determine the value of x. So you can use the cross product property. If you've ever talked about solving an equation, a proportion like this, you cross multiply or cross product, so that you can only do it when it's a fraction on each side. So you've done this back in junior high. So that's going to be 1 times x minus 5, which is x minus 5. 3 times 4 is 12. So x is 17. Okay. Check it out. Put it back in to verify. If you put 17 back in for x there, 17 minus 5 is 12. 4 twelfths reduces to 1/3. So it will have the same slope. Okay, so in that question, we prompted you through it. We told you what to do in parts A and B and C and D. In question 3, you actually have to do it all without being prompted. So notice that you're given the coordinates of 2 points, D and E, but in F, you're missing the Y value. So you have to figure out what the value of y is if these are collinear points. So that means the slope of DE is going to be the same as the slope of EF. Or you could do DE and DF, any two pairs. Okay, but I would avoid doing both. Okay, just hold on a sec. I would avoid using F in both sets, because then you're going to have to solve actually a quadratic. Probably a quadratic. You don't want to have to do that. So slope of DE, figure that out. Then slope of EF. Slope of EF will have y in it. Then you make them equal to each other. Okay, so do that right now. This one's really easy. Y minus 0 is y. 8 minus 6 is 2. So they already have the same denominator. So that means negative 1/2 has to equal y over 2. And so you can tell if those denominators are the same, then y is going to equal negative 1/2. Now, if you want to use the cross product property, then you can. It's the long way in this case. But then you would have 2y equals negative 2. Divide by 2, y equals negative 1. So either way, you're going to get negative 1. Okay, we're going to look at part D, slopes of parallel and perpendicular lines. Okay, so if you think about the first page was about collinear points. The slopes were all the same. Okay, if we think about parallel lines, it's going to be very similar. So parallel lines are lines that never intersect. So think about railroad train tracks on a straight track. Okay, those are always going to be the same distance apart. If they go in, then the train is going to go off the rails and have an accident. Right? They have to be the same distance apart. So it's always the distance between them is always constant. We don't want to be calculating that though. So you want to think about how their slopes compare. So what do you expect to be true about slopes of parallel lines then? Are they going to be the same or different, basically? So here's 2 parallel lines. If you look here, there's 2 parallel lines. What do you think the slope is? If you were skiing down this mountain here, that was the top of it, and someone else was here. Would it be the same slope? Yeah. Okay, so parallel lines are really easy in that their slopes are the same. Same or equal. The values will be equal, they're the same slope. Okay, perpendicular lines, are they going to be different, first of all? Yes. Okay, how do you think they're going to compare? Take a look. What about the signs of them? Will they be one positive, one negative? Will they both be positive, both be negative? Yeah, that example in particular. Okay, unless we do vertical and horizontal. So yeah, so they're going to be opposite in sign, and actually, they're not going to necessarily be. For example, this slope, if this was 2, this isn't going to be -2 necessarily, or ever really. So we have to learn something else about them. So for right now, they will be, be opposite in sign. And I'm just going to put ... because we're going to figure out more exact property about them in this first question. Okay, so they have positive and negative, and then what else about them? So let's look at the first one. So F is the blue, F is the blue one, G is the green one. Don't use points in terms of the formula, just find 2 points. And nice ones are the intercepts. So -6 there for X, +3 for the y-intercept. So if I draw my triangle, I'm going up 3 to the right 6. So my slope is going to be, will be 3/6, which reduces to 1/2. Always reduce it. Now if I do the same for the green, so if I look here at the y-intercept and then the x-intercept, draw my triangle, I'm going up 2 to the right 4, which reduces to 1/2. So what can you conclude? What we thought, the slopes of parallel lines are equal or the same. And the word parallel has 2 L's because think of parallel lines. There's 2 L's. There's 2 lines parallel to each other. So that's how I always remember it. Okay, perpendicular lines. Let's do this calculation. So let's do the H is the blue one. So again, I'll go from here to here. So up 3 to the right 4. Well, I'm not going to just randomly choose a number. You have to draw a triangle between 2 points. So count up. Okay, so then for the green, the X and Y intercepts are really nice on these ones. It won't necessarily be the case, but you always want to choose a point where the line is going through grid crossings, so you know it's exactly. So now when I draw my triangle here, I'm going down 4 to the right 3. So our fact that they're opposite in sign is true. What do you notice about the numerator and denominator? They're flipped. Okay, what's the math word for flipping a fraction like that? Reciprocal. So what we say for perpendicular slopes is that they are negative reciprocals of each other. The non-math way of saying it is flip it and change the sign. Okay? So here I was -4/3. H was 3/4. Okay, so here the slopes of perpendicular. Okay, I just got to wait for it to catch up because I think I spelt it wrong. Lines. Oh yeah, sorry, this should be perpendicular. Okay, lines are negative reciprocals of each other. Okay. Take a look at the horizontal vertical lines. Do they look perpendicular? What's angle measure between perpendicular? We didn't really talk about that actually. 90 degrees, right? If you got a protractor out and measured the angle here, that should be 90 degrees. This should be 90. This should be 90. This should be 90. Okay? If your grid paper is properly squared. So sometimes, like when we get into graphing a little bit more on your calculator, if we graph perpendicular lines, they might not look perpendicular because if you look at your screen here, is this screen rectangular or square? Rectangular. It's rectangular. So if you have going from -10 to +10 in both ways, it's actually stretching it out horizontally. You can square it. There's a way to just say z square and it will make it equal, but it won't necessarily look perpendicular depending on the grids. But these ones on your paper are all square grids, right? Equal distance between each unit. And so that's pretty obvious that they meet at 90 degrees. Now, in terms of the slopes, so J is the blue one, horizontal lines. What's the slope of a horizontal line? What did we learn the day before yesterday? 0. Okay, and then vertical, there is no run. There's a rise but no run, so you can't divide by 0, so it's undefined. Okay, so really, can you take the negative reciprocal of the word undefined? Well, no, like it's a word, right? But really what that meant was some number divided by 0, right? So if you flip that, the zero's on top, negative times 0 is still 0. So in a way, you're still taking the negative reciprocal, but you're not going to really do that negative reciprocal with horizontal and vertical lines. You just remember, a line that's horizontal, perpendicular to that will be vertical, right? So 0 and undefined are perpendicular to each other. So in this case, they are negative reciprocals. I'm going to put that, but we really, because I'm like, give me a sec to explain it. I'm about ready to get really annoyed with you. Like, just be quiet for a minute. Okay, so they are negative reciprocals. I put it in quotations because we're not really doing that, as I mentioned before. You have to, but memorize that 0 and undefined are perpendicular slopes. Well, it's one of those sticky things someone threw up there a few years ago. Before I even taught there in this room, so it's been there for a while. Okay. And then the last one is pretty normal, right? Slope of, okay, these are oblique lines, so they're neither parallel nor perpendicular. So what do we know about their slopes? Are they going to be the same? No. Are they going to be negative reciprocals?
Yes.
Are they perpendicular?
Yes.
No. It says they are nor perpendicular, means they're not perpendicular. Look at it. They don't look perpendicular to me.
Oh, I see.
So they're neither parallel nor perpendicular. They don't meet at 90 degrees. So probably their slopes will just be different. One will be positive, one will be negative, but there's not going to be a relationship between the numbers. So L is, so here join up the, oh, that actually doesn't go through that nicely there. So I'm going to choose the y-intercept and this point here. So that's down 2 to the right 5. And then for my for my green one, so that's y-intercept is good, and that x-intercept is good. So now we're going up 4 to the right 12, which reduces to 1/3. So you can see they're entirely different. They are opposite in sign, because one's positive and one's negative, but it doesn't have to be that way. Okay, they can be different slopes and both be positive, different slopes and both be negative. So the slopes are not equal. And they're not negative reciprocals either, right? Maybe I should put that in. And because negative reciprocals are not equal either. Okay, so let's do the chart. We're going to do the chart in 2. And maybe part of 3, and that's it for today. Oops, sorry. Okay, so in that chart or table, you're given the slope of a line in the first column, then it says slope of all lines parallel to that. So what do we know about slopes of parallel lines? Same. So what do I do? This is the easiest column ever. Exactly. Copy the slopes. That's all you do. So 2/3. Easiest marks ever. Don't ask.
Okay.
Well, you know who it's to. No one else does because I don't use names. Oh, okay. I don't use names. Okay, so slopes of all lines perpendicular. So you take the first column, or the second, really, because it's the same, and you flip it and change the sign. So 2/3 flipped is 3/2. Put a negative out front. We always put the negative out front or up top, never in the denominator, even when we're doing negative reciprocals. So here, even though it's sort of out front or up top, I'm going to, well, it doesn't really matter because we're taking the negative reciprocal, right? So now it's going to be positive 7/4. Okay. So 2, is not a fraction. So what will it be when we take the reciprocal, negative reciprocal of 2? Negative 1 over 2. Yep, because this is the same as 2 over 1, which we don't show it like that, but that really is what it is equal to. So we change the sign and flip that. 1/2 is the reciprocal of 2. Same thing in the next one. We don't show it, except maybe to help us with graphing things, which we will in the next part of the unit. But that's the same as -5 over 1, or the negative out front. When we flip that, that's going to be 1/5, and it'll be positive because it was negative to start. And then the last two, that's where we don't really take the negative reciprocal. We think about memorizing. So slope of a horizontal line, perpendicular to that will be a vertical line. So if we start with 0, we'll be undefined. Which is 0. There's no opposite to 0. That's why we're not doing that.
Negative opposite. Undefined is negative. Opposite of 0, so negative undefined is the opposite of 0.
Okay, well, we don't show it like that. So 0 slope.
Opposite of 0 is negative undefined.
Okay, listening please. Listening for a sec. So horizontal slope is 0. Vertical is perpendicular to that. That has an undefined slope. So start with this. Horizontal is what's perpendicular. So just memorize it, because we don't use values in the undefined. It is undefined because you're dividing by 0, but we don't show that. Okay, so you can't leave something with a slope of 5 divided by 0. You have to say undefined. Okay, so just remember that. Okay, and let's just do 3A, and then we're done for today. We'll finish up on Monday. So it says draw a line. So those of you that don't have a ruler yet or a straight edge, you need to get one. So remember how I gave you, if you have a calculator where it has batteries, so the Casios that have batteries, or TI, that's a straight edge. Okay, you don't need a long one, but that's a straight edge. Just remember to put it back on so you don't lose that. Okay, or buy a ruler, a straight edge of some kind. So this says draw the line passing through -4, 2. So you want to plot that, and I'll just call that A. I don't need to label it, except with the letter A. And we want to draw a line that passes through that, that's parallel to the line passing through these 2 points. So I guess you could plot those 2 points, B and C, and find the slope between them. Or you could find the slope of BC using the formula. I'll do that first, and then we'll check by graphing it. So from B to C, it's 4 minus 1 over 5 minus -2. So that's 3/7. Okay? So we want a line that goes through A with a slope of 3/7 because it's parallel, right? So slope, sometimes you might see slope M with 2 parallel lines next to it. That doesn't look so good, just a sec. Okay, and that means the slope parallel is 3/7 as well. So now that means my rise is 3 and my run is 7. So I go up 3 to the right 7. Okay, it's always good to try to have more than 2 points. What's up? Yep, I'm going to do that in a sec. Yep, that's what I'm going to do in a sec. I just said that I was going to do that in a sec, so just hold on a sec. Okay, I can only do one thing at a time. So up 3 to the right 7. If I try to go up 3 again to the right 7, I'm going to run out of space. If I try to go down, so you could show this, you could get other points by doing -3 over -7. So That's just work. That's not the lowest terms of the slope, but that means we could go down 3 to the right 7. But again, we're going to run out of space. So really, we can only get 2 within this grid. So then get your straight edge. Okay, and I'm going to join these up, which is hard on my computer here. So I'm going to estimate a little bit. Give me a sec to fix the line up. It seems to be frozen. Sec. Oh, great. Now it's, let me just, okay, so when you draw a line through that, we're going to then put arrows on the end. Because it says a line. A line segment ends. This has a line, so it's going to go through that. Now, if you wanted to, rather than using the formula, you could plot -2, 1 and 5, 4. And then join those up and look at what the slope is there. So we're going up 3 to the right 7, which is what we found it out to be. So then from point A, we go up 3 to the right 7. It's the same final result. Okay, so that's where we're going to stop for today. We will continue on with question 4 on Monday. But in terms of your assigned work, you can still do those textbook questions, okay? At least all till the 20s. Okay, so make sure you are catching up on anything this week.